Welcome back to our deep dive on fine-tuning large language models. In our last chapter, we kind of mapped out the whole journey. Well, today, we're rolling up our sleeves and getting our hands dirty with what is, without a doubt, the most critical, foundational step of them all, data preparation.
And let's be absolutely crystal clear about this right from the get-go. This isn't just some preliminary task, it is everything. The quality of your data is going to directly decide whether your fine-tuned model is a huge success or a total failure. You've heard it a million times, garbage in, garbage out. That's the oldest rule in the book, and believe me, it has never been more true than it is with LLMs.
So you might remember this from last time, the entire 7-stage fine-tuning pipeline. We're going to cover all of these, of course. But just look at where this whole journey kicks off. Stage 1, data preparation. It's the bedrock. Every single thing that follows is built right on top of it.
So here's our game plan for today. We're going to start with the data foundation, then move through our core refinery pipeline, take a look at some really cool advanced data crafting techniques, talk about how to navigate the common hazards, and finally, lay out the success blueprint. Think of it like we're taking raw ore and turning it into high-octane model fuel.
Okay, let's just dive right in. Why can't we just take a massive pile of raw text and dump it into our model? Well, because raw data is kind of like unrefined ore. It's got a ton of potential, for sure, but it's also packed with impurities, all kinds of noise, biases, and inconsistencies that can totally confuse, mislead, or even poison your model.
And that is exactly where our core refinery pipeline comes into play. This is the step-by-step process we use to transform that raw, messy material into clean, structured, high-quality fuel that our model can actually learn from in a meaningful way.
Our refinery pipeline really boils down to 4 key stages. First, we gather up all the raw materials. Then, we clean them up and pre-process them. After that, we tackle a super important step, balancing the data to make sure our model isn't biased. And finally, we split our finished product up for training and testing. So let's break each of these down.
Step 1, it's all about gathering our raw materials. This data could be hiding anywhere, in CSV files, scraped from websites, or pulled from huge databases. The Python world gives us these amazing tools like pandas for spreadsheets, beautiful soup for grabbing text from web pages, and Bodo 3 for getting stuff out of the cloud. But you don't always have to start from zero. There are awesome public datasets like LLM Explorer and others that can give you a huge head start.
So once we have the data, this is often what it looks like. Yeah, a total mess, right? It's got typos, weird capitalization, random punctuation marks, extra spaces, just all this noise that adds zero value and can seriously confuse the model.
And boom, this is the transformation. We clean up that mess, and then we do something really important called tokenization. Now that's just a fancy word for breaking down sentences into the little pieces, the words or parts of words that the model can actually understand. And we've got powerful libraries like Spacey, NLTK, and Hugging Face transformers that are the absolute go-to tools for this job.
Okay, now for a problem that trips up so many projects, data imbalance. Just imagine you're building a fraud detector, but 99% of your data is just normal, non-fraudulent transactions. A lazy model could get 99% accuracy by just guessing not fraud every single time. It would be totally useless in the real world. This is exactly that problem. The model just learns to ignore the really important but rare examples.
So how do we fix it? Well, one popular trick is oversampling. We use techniques like SMOTE to basically create more synthetic examples of the rare stuff to balance things out. Or we can tweak the model's training rules. It's kind of like telling the model, hey, you're going to get a much bigger penalty if you get a rare fraud case wrong than if you mess up a normal one. This forces it to pay way more attention to that important minority class.
All right, the final step in our core pipeline is splitting up our beautiful, clean data. Now, why do we do this? Well, you can't use the same data to teach the model and to test it. That's basically like giving a student the answers to the test beforehand. You end up with a model that looks super smart, but completely falls apart on new, unseen data. So we split it. A big training set to teach the model, a validation set to fine-tune it, and a final, untouched test set for the ultimate, unbiased final exam.
So we've covered the essentials, but to really level up our game, we need to talk about advanced data crafting. These are the techniques that take a good data set and make it a great one. This is how we create that premium, high-octane fuel for our model.
First up is data annotation, which is just labeling your data. The gold standard here is manual annotation by human experts. The accuracy is amazing, but it's also incredibly slow, and you guessed it, expensive. On the other end, you've got automated tools like Snorkel or Amazon SageMaker that can label data at lightning speed, but you always have to double-check their work. It's a classic trade-off between quality, speed, and cost.
But what if you just don't have enough data to begin with? That's a super common problem, and that's where data augmentation comes to the rescue. It's a whole set of clever techniques for creating more training examples from the ones you already have. For instance, let's say we start with just this one sentence.
Like, the AI model performed well. We can use something called word embeddings, which is basically a way for the model to know which words mean similar things to swap out performed well for performance was excellent. Boom, a new sentence. Another really slick trick is back translation. You translate the sentence to Spanish, then immediately translate it back to English. You often get a slightly different phrasing of the same idea, which helps make your model way more flexible.
And this is where things get really futuristic. We can actually use other, bigger LLMs to create data for our fine-tuning. With some clever prompt engineering, we can get a model like GPT-4 to generate thousands of diverse, high-quality training examples that are perfectly tailored for our task. It's an incredibly powerful idea.
Of course, this whole process is loaded with potential traps. So let's talk about the common refinery hazards, the pitfalls that can absolutely sabotage your project if you're not paying attention.
These are the big ones. Domain mismatch. That's like trying to train a legal chatbot with Twitter data. The context is all wrong. Data bias is when your data reflects societal stereotypes and then your model does too, which is a huge problem. Then you've got just not having enough data, having inconsistent labels that confuse the model, and of course, massive ethical concerns around privacy. Any one of these can totally sink your project.
So after all that, how do we actually guarantee success? Well, it all comes down to following a clear, actionable blueprint that's built on best practices.
And here it is. It all starts with high-quality data. Then you pre-process it effectively. You have to manage imbalance for fairness and accuracy. Next, you strategically augment and annotate to make your dataset even stronger. And critically, you handle it all ethically. And finally, you never stop evaluating and iterating. This isn't a one-and-done checklist. It's a continuous cycle of improvement.
If there is one single thing you take away from all this, let it be this. Data preparation isn't just a step in the process. It is the absolute backbone of fine-tuning. And if you have a weak backbone, the whole thing is just going to collapse.
Which leads me to the last question I want to leave you with. Your model is only and will only ever be as good as the fuel you put into it. So take a hard look at your own projects. Is your data really refined enough for the job?
Okay, so we've now crafted our high-quality fuel. In our next chapter, we're going to take that fuel and get the engine ready to go by tackling model initialization. Make sure you're subscribed so you do not miss the next stage of our fine-tuning journey. Thanks for watching.